All right, section 2.3, the derivative. Now remember, the big idea here was not doing the algebra versions of derivative, but understanding what they are, what they mean, what they're describing, how do we find them. So we do need to know how to use the formal definition of derivative, which is the limit as h approaches 0 of f of x plus h minus f of x all divided by h. But we also need to know the different derivative notations, the prime notation, the change in x over change in y type notation. So don't let those fool you. Make sure you understand that they are describing instantaneous rate of change. They change, the speed, how fast something is occurring, how much a stock is going up at an instant, how fast your car is traveling, how fast a rocket's passing through the air. Just a comparison between two variables, how much one variable is changing, the y variable, in comparison with the x variable, or the time with the distance, or the price value, the price of a stock versus the, who cares, whatever you want to do, the price of a stock versus the S&P 500, whatever kind of comparison you want to do. At a moment, how are those things changing? Okay, on a graph, what does that look like? What does a derivative look like? Well, it is the tangent line to the graph at an instant. You need to be able to answer questions related to change and how those relate to a derivative. Draw derivative graphs given position graphs, or vice versa. Okay, so here's the first problem. This would be very similar to the last bullet there, which is being able to draw a derivative graph. So here, if I give you this function and say, I need you to draw me a derivative graph, you say, okay, well, first off, between the x values of 0 and 1, I should have positive derivatives. Graph A, graph B, and graph C all have positive values. So therefore, I can't make a decision based off of that. Then after 1, going to 2, all of my slopes are negative. So therefore, I should have something that goes down to the negatives. So therefore, I do go down at 2, we actually go down, we need to be negative in the 1s. This one's still positive in the 1s. This graph B never goes negative. This graph, oh, here we go, at 1 it goes negative, and then again at 2 it should jump to positive. So there we go. So therefore, the derivative graph for this function right here would be C. Now, the other thing you notice is that this has sharp corners. So therefore, you don't really know, it never kind of levels off. So therefore, that's another reason why you see these jumps, is you're jumping instantly from positive to negatives, and vice versa. All right, so now for the other graphs. So we know this graph was C. All right, I got that done. For this one now, we see it should start off positives, but remember they both start off positive. And then it's going to have a maximum. So if this graph has a slope of 0, if the tangent line has a slope of 0, somewhere right around 1.5, that means we should have an x-intercept, because it would have these are all those slopes, so therefore it should have a value of 0 right around 1.5. So there you go. So this graph is A. And if this was a test, we just immediately throw this in here and say B. But let's make sure we can see it. So starts off with little, you see they're positive, but they're small. Small. Then they get steeper, 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 but then they start to get less steep, less steep, less steep, and back down to being small, but always positive. So here we see they get steeper, 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 steeper. Then they start to get less, 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 and small, 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 but always staying positive. So we can see that's why this one matches with C. Okay, and for problem 7, using the graph, answer the following questions. At what values does the graph of f of x have a horizontal tangent line? All right, so again, we would have a horizontal tangent there at 1, because the graph would have positive tangent lines, less, less, less steep, 0. We're going to have another one at 3. We're going to have another one at 4. So therefore, we have them at x equals 3. Sorry, excuse me. 1, 3, and 4. So, and later on, in a couple sections, we're going to talk about how can we use that, what is that, why is that important, and what you can see already is all those horizontal tangent lines happen at max and min values. Okay? And then at what value of x is the value of f prime the largest and smallest? So they want to say, what is the largest and smallest derivative? Now that's a really good question. That's what you should be looking at, because what would you be looking for in the position graph? What would you be trying to see the largest and smallest f prime values? So largest value would mean a large slope. Large slope means it's really steep. So therefore, it looks like we are the steepest, somewhere right in here, and approximating is okay. We're going to algebraically solve this later. So therefore, let's say it's about 3.5. So it would have the largest slope at about 3.5. X equals 3.5. Let's try this one more time. X is about 3.5. Okay, now the smallest slope, I don't like that verbiage, and that's my own verbiage, I just see it right now. The smallest could mean most negative, or smallest could mean the smallest number. So if it's the smallest number, we're saying 0, and it would be 0 at 1, 3, and 4, just like the last problem. If they mean most negative, then the steepest in the negative direction, well, then it looks like it might be right about there or right about there. Looks like it'd be about a tie. So therefore, I'm going to say it has the smallest or most negative at x is about 1.5 and 5. But again, remember, if we really wanted to use smallest, this is what I would really want you to say is the x equals 1, 3, and 4. You know, it's the smallest, it's 0, because these are speeds. And even if a speed is positive or negative, if someone tells you, you know, you're traveling 65 miles per hour towards Las Vegas or 100 miles per hour home, which one's fastest? It's the 100 miles an hour. Even though it happens to be a negative value, it's a big value, not a little value. So really, truthfully, this would be the answer, but you can always ask me on a test. Okay, hope that helps.